Okay.
Let's see. The wires connecting everything.
Okay, so I'll text him.
Are we waiting for Irvin?
Mm-hmm.
I think, did you guys get his email?
Yeah, his phone's working again.
Oh, okay. It just seems like bad things keep happening to him.
I know, it's poor
I know, that poor guy.
Wi-Fi, his phone. Oh, it's rough.
And someone ran into his internet box.
Oh, man.
Oh, sorry, that was me. I always forget that it's a group message. Well, I guess, did you guys have any questions on the...
I
Okay.
did. So, like, on the prep work, it says like, it was talking about, like, investment property ages. And I'm not sure, it said we were supposed to use the SPSS or something, you know? But I wasn't sure how to insert that into SPSS and, like, extract data from that. All I could find was, like, okay, I have this information, but I don't know how to make a graph out of it.
Yeah, I didn't.
That's kind of my question also.
Me too.
Hey!
There he is.
I feel like SPSS is just annoying.
Oh, it is the worst.
It's helpful when you can, like, just tell it to give you these calculations or whatever, but then it's like plugging. I don't even know how to plug in the information because I know how to get it if it's set up on the website already.
Yeah.
But if it's not, I don't know how to make my own. So all of the end, like the end of the preparation assignment, I couldn't even do because I was like, I can't compute this without plugging it into SPSS, and I don't even know how to do that. So.
I know. That's the truth.
Where it was like find the p-value and all that.
Yeah.
Yeah.
It was like, okay, so let me scroll down here. At the bottom, it was like, okay, so you can calculate T, and you can find the state of degrees of freedom, but you can't sketch the T distribution and shade the area, and you can't compute the p-value, and because of that, you can't know if you have to reject the null or not, because, I mean, is there a way to plug it in? We just are supposed to know that somehow?
I think it was one of the video tutorials, but it sounds so bad, I just wasn't feeling it. I was like, you know what? I don't know how to do it.
Oh, so it was on a video?
I'm thinking so, because it says 2, 5, and 7 are required. Let's see, that was number 6. Maybe that's what they meant, was 6, but I guess we could watch those. Let's see.
Maybe we should, because I feel like we're going to encounter this.
Yeah, probably.
Okay. Maybe I'll share my screen.
Okay.
That
Good
way it'll
idea.
play the video. Hopefully. Okay.
Hello, this is Brother Kumar from the Math Department. This is a supplemental video dealing with SPSS commands for inference for one-beat sigma count. And these are the three commands that you should know in SPSS for one sample of your one-beat sigma count. First, we have to deal with the explore command. We've seen that before, but I'll cover it. Then also cover the one sample T command in SPSS. And then finally wrap it up with the C4. So let's start off.
Is this the right video we want?
What I'll be doing throughout this is use the.
Is it showing us how to input data?
If I want to do the export, I'll do analyze.
Well, he already has data.
Yeah.
And then if I want.
So do we just make it in a line like he does where it says body temp and we just put all of those numbers down in a row?
Maybe.
Well, like you would just list it yourself. The only thing is, like when I was looking at doing that, if you click on the second tab at the bottom, it says variable view, and then you have to punch in some kind of qualification for your variables, and I have no idea what that is.
Oh,
that's for like for example, if it's asking find like the parameters for like a 90% confidence interval, that's where you would put the 90. Or if it's asking if you have a hypothesis and you were putting at a confidence interval of like 0.05, that's where you would put it. That makes sense.
I just wonder.
Go ahead.
Well, so do you know how to, like, for example, on the preparation assignment, it was talking about like using information from SPSS, but we would have to punch in the info about investing property ages. So you would know how to do that? What?
It was pretty. I thought it was pretty easy. So.
No, that's like so hard.
Okay, we're going off of Irvin this one.
Yeah. Or do you want to show us, like, just an example, maybe? Could you share your screen before we do it? Because I want to help.
Yeah. Okay, just 1 second. Let me find the... Okay, how do I do this screen thing? I forgot.
I think there's an option on the left.
Yeah.
Screen share.
Yeah.
Okay. Let's see. Let me get on this thing really quick.
There we go.
Oh, now it decides to load up fast. Yeah, when I was doing the individual prep work, it was going slow and it was driving me nuts. Right. So you're asking for the homeowners retailing, right?
Yeah.
Yeah.
Okay.
There were problems about it, but then I was like, I can't get the answers unless I know how to punch this into SPSS.
Okay. You guys can still see my screen, right?
Yeah.
Okay, cool. Just let me punch these in super fast. Because I tried copying and pasting it and like didn't work.
So you just opened up a new.
Yeah.
Okay.
145, 46, 56, 49, 48, 38. Okay, for one of the questions it said like it was asking for like a 90%
Mm-hmm.
or something like that. What is it?
Let me check.
So I can show you how.
It says, well, there's a 0.05 level of significance, and then
0.05? Okay, I think that one's it.
okay.
Okay, so you go to Analyze,
Mm-hmm.
and then you're gonna go to Descriptive Statistics, and go to Explore. Switch that over. Hit the Statistics button. You see that little box right there?
Uh-huh.
That's where you put the whatever confidence interval it's asking for. So it's 0.05.
Yeah.
Continue. Oh, wait. Create 95%. Okay, 95%. So it's already in there.
Okay.
Then you hit continue.
Is that problem number 5?
Okay. And then it'll show you the mean right there, confidence interval, your standard deviation.
Oh.
Yeah, because in the book it says the number one problem that confuses the students the most is that they forget to put the 95% or whatever percent confidence level they need in that box, and that kind of throws the whole thing off.
Okay.
So for the next one, you'd put a 99 in the box.
Yeah, and the next time you put 99 or
Hmm.
whatever percentage it's asking.
Okay. I think that was really, really helpful.
Yes,
Cool.
very.
Okay, cool.
All right. Well, I feel more prepared now.
Me too.
Okay. Oh, me too, also.
Should we start it?
Let's do it.
Do it to you.
Okay, let's see. Ah,
Okay, where are we?
Less than 11, right? Yeah. Got it.
Okay, are we all there?
We know Urban's there.
You're still
Oh, my-
screen sharing.
Oh, I thought I turned that off.
We're all gonna copy your answer.
Ooh, let's do it.
I'm gonna put answer 2 is -9. Answer 3 is Kentucky, and then I'll just switch the questions later. Okay, am I off of it?
Yeah, you're good.
Yeah.
Okay.
Okay,
Alright,
I can start.
Okay, go for it.
Okay. In previous lessons, we have assumed the population standard deviation sigma was known. In this lesson, we are making a different assumption about sigma. What has changed?
We assume standard deviation is unknown.
Yep. Okay.
I read the next one. The null hypothesis is mean equal to 8, and the alternative hypothesis is the mean is greater than 8, and the population standard deviation is not known. Becker collects a sample of the size n and computes the sample mean to equal 11, and, oh crap, that means standard deviation is sample, right? Is 6. And then use so is the standard deviation known?
No.
No.
Is that a trick question?
Seems like it.
No,
It's
because the
not.
S represents the S is like the sample standard deviation, while the sigma represents the population standard deviation.
Right. So, no, right?
So we
Yeah.
don't know the sigma, but we know what the S is.
Right.
And we can figure out what t is, because it's like the z-value, only it's not technically the z-value.
I'm really glad we don't have to memorize any of these equations.
Oh my gosh.
Same stuff, but you just gotta switch out.
Yeah.
some
After a
letters.
while, you kind of memorize it on your own.
Yeah.
But like they keep switching the different like.
Variables and stuff.
Yeah. Okay. So,
I got. So we would put the null hypothesis in, right? Not the alternative. Either way it's 8, but still.
Yeah. Yeah, I think yeah, you always put in the null.
Okay.
Because it's the one you're always wanting to try to
To
disprove.
prove it. Okay. Okay, I got 1.5.
Me too.
my phone is not doing the square root. What is the square root of 6? Wait, the sample size.
Of 9.
9.
Of
3.
9. 3, okay. So it's 6 divided by 3, so it's 2.
Yep.
So it's 3 divided by 2, right?
Yep.
1.5?
Yep.
That's what I get too.
Cool beans.
5. Okay. I can read the next one.
Go for it.
Use the following values which were pulled from the data file body temp. Copy and paste them into the software you are assigned to use.
God.
Quantitative inference. I'm not gonna read that. Using the null hypothesis. Using the null hypothesis of mu equals 98.6, an alternative hypothesis of mu is less than 98.6, and level of significance is 0.05.
Okay, here it comes.
What is
I wonder if can we copy and paste this into the new one, I wonder?
That's what it said it could. I'm gonna try it out. Hopefully it'll
Let's see.
work for me.
I'm gonna see.
Oh, it worked! I think.
Yeah, got it.
Yay! I think mine worked too.
Hallelujah.
Okay, so then we go to analyze, descriptive statistics, and what is the next part?
Explore, right?
Explore.
Yeah, Explorer.
Explore.
And what was it asking?
The sample mean.
Sample mean?
Yeah, so I think we just put it in there and press OK.
Yeah, you just push OK. Mine popped out as 98.22.
Still loading.
That's what I got. 98.22.
Yep.
0. Should we be able to do 98.220?
What does it say? Round to 3 decimal. Yeah, so 98.220.
Okay.
Yes.
And then,
What is S?
so would S be 0.922?
It should be the standard deviation, 0.922. Yeah.
Okay.
Yep.
And then we have to figure out the t-square, right?
Yeah, so it would be the mean minus the U thing divided by.
Which one's the mu thing?
Wait, okay, hold on. Okay, we're taking the square root of the sample size.
But we don't. Oh, we have to count them. 1, 2, 3, 4. I got 20.
Yeah, there's 20.
Yeah, that's what I got. I got 20 too.
Okay, so the square root of 20. Can anyone give me that?
Yeah. Hold on. It's 4.47.
Okay.
Yeah.
Thank you.
You're welcome. What was the standard deviation? 0.922? Yeah.
Uh-huh.
Okay, I got negative 1.84.
Yeah, that's what I got too.
So
Hold on
the
a
negative
second.
is
Yeah.
right.
Okay, so. Oh gosh, what am I doing? Okay. It's so much harder when I'm using my phone and this weird calculator. It's so slow.
You're totally fine.
Okay, did you get negative 1.842299?
Yeah, yours is going to be a little different. So I got negative 1.843.
Yeah, me too.
Okay.
Okay, because just with the rounding, screw it, it's funny.
0.843.
Yes.
Yeah.
Okay, that's good.
Okay, so what is the p-value? Oh, how do we use p-value again?
Is that analyze again?
Let's see.
I don't know if I'm like doing it right, but for some reason I tried figuring it out like the way the book said, and SPSS I never got it right on the SPSS, but I just plugged it into the applet, and somehow the applet
Oh.
gave me the right answer. But it says not to use the applet, so I'm kind of confused. It's like, well, the applet's showing me the right answer, but SPSS gives me a totally completely different number. I don't know where it comes from.
Huh.
Yeah, that's really weird.
So you just plugged in the t-value into the applet?
That's what I did. I'm like, but I could be wrong. Maybe it's just a coincidence that it happened to be twice.
I think it also depends on your t-value, because if your t-value is really extreme, I think that would affect it. Wait, no. It's not the confidence interval, it's the freedom something.
Yeah. Degrees of freedom.
Yeah, degrees of freedom. So if you have a lot of degrees of freedom, meaning you have a bigger sample size, then you'll be really close to the normal probability applet. And I think because we have 20, it's a little bit bigger, and it'd probably be close, but...
Okay, so are we supposed to plug it into the SPSS?
It looks like it, I think.
I think it's you do the one you guys know how to do the one sample test, right?
It's compare means, right?
Yeah. And then you plug in the 0.05.
So how do you do that? You do analyze?
And then just right below descriptive statistics, compare means.
Okay,
Mm-hmm.
And then you're gonna hit the one sample t-test.
gotcha.
And then on the statistics bar, you're gonna pop that up open. And then on the little tiny square, you're gonna put the 0.05.
Okay, I did something wrong. I don't have a statistics bar. What did I do wrong?
Maybe I was wrong. Hold on, let me check.
So analyze, compare means, one sample test.
Oh, sorry. Oh, it's right below the box where it says test variables, where it says test value.
Yeah,
Oh.
test value.
Yeah, my bad.
And you type in point.
0.05.
And then we get the what are we looking for, the p-value?
Yeah.
So that would be df, or is that, no, that's degrees of freedom, huh?
Because in the book, it says you want to double click on where it says sig parentheses two-tailed.
Double
But
click
it's
there?
always like, yeah, and it's supposed to like, and when it pops up in a black box, you just put the mouse over it, and then it'll bring up the p-value.
Whoa.
And that's what I was worried about, because on the individual prep work, it would give me a completely different answer on the key, while I have like something to like the 10th power or something like that, and I know that's not right.
Oh, okay, so when I do that, I got 3.3674 e to the negative 40.
Me too.
Yeah, that's what I got too.
Yeah. Okay. So wait, how do we put that in our answer?
That is a good
If you
question.
round it to 3 decimal places, it's going to be 0.000.
Oh, man.
The book. That's what the answers in the book are. Like in the text, it's like the p-values are 0.000.
Yeah, what confused me is that on the prep assignment, when I looked at the key, like for the last problem, it says use your software to compute the p-value,
Mm-hmm.
and the answer is 0.907. I don't know how.
What?
I don't know how
Wait,
that
let me
is.
check. Okay, p-value 0.9077 for the bottom one. What the heck?
And the weird thing is that I tried, well, if I put it into the applet, and when I plugged into the applet, it gave me that p-value right there, and so that's why I was confused.
Well, at the bottom of in the reading, toward the bottom, it says the p-value is shaded in green on the applet. Well,
Is there
that the
a
applet?
different applet?
I don't know.
No, that's the same one. I guess they just chose the color green to.
But are they using the applet then?
Let me just check here. Okay, so if it was following the applet, it would be negative point.
0.0653.
Yeah, okay. It's really close if you do use the applet. I think it's close, but it's not exact.
So it's close to what now? Sorry.
So if you were to use, okay, so just checking on the homework assignment, if you were to punch in the t value at the bottom, to the normal probability applet, the value comes out to 0.9069, and the real value is 0.9077. So that's pretty close.
Oh yeah.
But
So should we use the p? Should we use that?
if we don't know how to do it any other way, then that's our best bet. But I don't think it's perfect.
Yeah, because otherwise our answer is 0.000.
Yeah, it just goes on for like, what, 40 more times?
Yeah.
So, let's see here. Compute the p-value.
Because in the example of the book, it says the test statistic of the t, and I plug that in, and that's where I kind of base it off. So I plugged in negative 1.219, and then I shaded both sides of the tail because that problem's asking for like either or. And then it gave me the p-value of 0.228, and that's where I kind of based that off of.
Oh. Okay, this is interesting.
You're saying we should plug maybe the t-score in?
That's what it kind of feels like.
Yeah, that's what I did, and because it's asking for less than, so it's going to be on the left side of where the t-score is, and I got 0.033.
Yeah. Me too.
That's so weird. Hopefully we don't get marked off on that one.
And if we can also email her. This is confusing. Watch our video.
Yeah. So are we going to go with the applet value?
I think
think so.
Yeah, we can just maybe come back to it if we feel like we saw something else that might help.
Okay. So what is the correct decision? We should fail to reject it, right?
Yeah.
No,
So
we would reject it because it's less than 0.05.
Yeah.
You're right.
Less than 0.05. Yeah, okay, so fail to reject the null hypothesis.
Yeah.
Okay, yeah.
Hey, we get to do this all over again.
Oh boy.
Oh, good. Here we go.
Okay, using the
Use the
following.
following values, which were told. Oops, go ahead.
Oh no, you go. Go for it.
Okay, for the data file baby boom, these values are the wait time in minutes between births at a hospital. Copy and paste them into the software. The hospital claims that the average time between births is 40 minutes and plans its resource allocation based on this claim. You want to test their claim. You select that the hypothesis is equals to 40. And yours is not equal to 40. Okay, what is the p-value?
Ah, not the p-value again.
Oh, no. Thing we're not doing so well on.
Okay.
Where did it go?
Okay, so descriptive statistics, explore. Okay. So the mean is 40.0476.
And the standard deviation is 36.35.
Yeah.
Ugh.
40.047.
Uh-huh.
Get mine to work.
6.3.
So what are you using? Are you guys trying to find the t-score?
Yeah.
Yeah.
So what did you use for your sample mean? Oh, we just had to add them up, huh? And then divide by how many there are?
Yeah.
Well, you can do that, or you can actually
I have.
do the descriptive statistics thing.
Oh yeah.
I'm gonna go grab my other calculator.
Well, how many is it? 15? No, hold on. 2.
You got 21 for the
21?
sample size. Is that right?
Yeah, that's what I got too.
Okay.
I thought I was going crazy, and I was like counting one more.
I got 0.005999852.
I got 0.006.
Yeah, just about.
For the t-score?
Yeah.
Okay. Oh my goodness.
Yes. Okay, just to make sure I got this right, you guys have got the mean for 40.047
Yeah.
and the standard deviation 36.355.
Right.
Okay.
In the one sample test, it says the T is 5.047. I don't know if that means anything.
Yeah, that's what I've been getting a lot too, and because one by hand gives me the answer, but like for some, I don't know why what it gives.
Oh.
What incarnations?
Wait, what did you get for your T?
Well, when I did it by hand, I got 0.006,
And that's what I
but
got too.
Yeah.
on the SPSS it says it's
5.02.
5.05.
Oh, you got
That's
5.
weird.
Mm.
Maybe that's because I did it with the test value of 0.01. I don't know if that makes a difference, but
Oh, is it a test value of 0.01?
uh-huh.
Oh. Oopsie daisy.
Or a level of significance.
0.01. Because for the p-value, it's giving me 0.000062.
Yeah, me too.
When you use 0.001 or 01?
Uh-huh.
Oh.
I honestly don't know. Mm.
Okay.
Or maybe the key is wrong on that answer, and it's really the 0.000 whatever it gives you.
Okay, this is interesting. Oh no, it's not. It's nothing. Okay. So if we use the t-score that we calculated and do the 0.006, it makes more sense to use that than 5.047 because that doesn't even fit on the applet, I guess. But I mean, I don't know if that makes a difference.
Mhm.
But so I got the probability to be 0.5024.
Let me see here. Okay.
How are you doing that again?
So I just did the t-score by hand
Uh-huh.
and then plugged that into the probability applet.
Okay, let me see.
Oh, but it'd be different because it's everything. I honestly don't know if you can use the applet because it's just not equal to.
Because the normal probability applet isn't quite exactly the same shape.
Yeah.
Oh my. Okay.
It's confusing.
Erg.
I think I'm gonna email her either later tonight or tomorrow and ask her what she meant by the p-value and the assignment. If there's anything different, we need to know than what it says in the book.
Yeah.
It's a good idea.
Yeah.
Full significance.
Oh, okay, wait. Hold on. So the equal to sign. I'm just reading through the notes here. It says for mu is not equal to whatever number, the p-value is area in the two-tails beyond the test statistic. In other words, the p-value is equal to the sig two-tailed. And then if it's less than, it's the area to the left, which gives you the area. So you just divide the sig two-tailed by 2.
So in that case, it would be like 0.9952. But then again, it comes back to the shape of this normal probability.
So you divide the test statistic by 2?
No, you divide where it says the sig two-tailed by 2. So on the one sample test.
So it's 0. So it's the 0.00061.
Yeah.
Which would mean that the whole thing is basically highlighted.
Right.
Except for smack in the middle.
Yeah.
So you would have 0.9952 for the p-value. Which, I mean, isn't completely ridiculous, but still no guarantee on like if it's the right answer or not.
So you're saying the p-value is what you're thinking?
According to SPSS, it equals. Hold on, I'm still reading.
Because now I got 0.00003 because I divided it by 2.
Wait, which number are you talking about? 11 still?
Yeah.
Yeah.
Okay, hold on.
We're still on 11, right?
Yeah.
Okay. I
I
was like, did you guys get ahead or something?
Sorry. So what did you divided? So for this one, we wouldn't have to divide anything because we're just saying it's not equal.
Right.
So I got it to be, come on. 0.000062
For the area?
for the p-value.
And you're just getting that from your...
From the t-test, yeah, one sample.
Okay, let me check that. I don't know, that sounds so wrong.
I know. I just wish that the home, or the, I mean...
Yeah, the reading doesn't really give a way to test that.
Calculate. Because it's saying use the applet and shade both sides for this test, and then the last half of the book says click on the sig two-tailed and it'll give you the p-value. I'm like, well, which one is it?
And then there's not like a probability applet for this either.
Mm-mm.
Maybe there is. I can Google it.
Oh, yeah.
Oh, it's like this.
Quick p-value from t-score calculator. Google! Okay,
Yay!
so the t-score was 0.006.
Yeah.
And what is DF again? Degrees
It was 20.
freedom.
Yeah,
So 20. So significance level 0.05. One-tailed or two-tailed?
No, it's 0.01 significance level.
Yeah.
Oh, okay. And
It's a
two-tailed?
one-tailed.
One-tailed?
Or is it one-tailed?
I thought it was
Oh, sorry, I was thinking of the last question. My bad. Yeah, it's two-tailed.
Okay, here we go. Calculate. The p-value is 0.995272.
Oh, yay! So it is the same as the applet.
Yeah.
So,
So I
what was
wasn't
it?
going crazy.
Yeah,
995 what?
0.995272.
So just 0.995. Okay.
Yeah, I'm gonna bookmark this page for sure.
Should we check the other one we had? Do you want to check number 9 just to be sure?
Yeah.
Come on, 0.033.
So
we
the score was 1.843. Negative 1.843. Yeah.
the T-score was negative what?
1.843.
1.843, and then the DF
Should be 19.
19. The significance level 0.05. And is it one-tailed or two-tailed?
I think
It is 1.
Oh, is it one?
Because we want the left side, right?
Oh, okay, yeah.
Okay, so calculate. The p-value is 0.040494.
Can you do it for two-tailed?
Yeah. 0.080987.
Whoa, okay.
Yikes.
So, let's see.
So I wonder how I goofed that up.
Well, how did the applet work for this one, for the second one, but not this first one?
Hold on. The first one says...
Oh, because did we shade the wrong side? Did we shade one side or two?
Because it's asking for less than, it says the p-value is the area in the tail to the left. And because we got a negative t number, so it'll just be whatever it's on that side.
But is it asking for the less than? Because I thought...
Because it's
No,
asking for less than, so it's going to go to the
What did your
the one on
calculator
the
give you?
left.
So this calculator for one-tailed at a significance level of 0.05 and a t-score of negative 1.843 gave us a p-value of 0.040494.
Oh, wow, that's not even...
Actually, that's not bad because I have 0.033.
Yeah.
And if you were to round, that would be 0.04. But, like, you don't round because it's a 3.
Yeah.
I don't think that's that bad, actually.
But if we put that into what's going to come out right on our answer? Like, what is she using to round?
Yeah, that's true. I don't know.
Maybe the probability applet that's been given to us, I would assume.
So should we go with 0.033?
Maybe, yeah. Ah!
0.033.
Excuse me.
Okay, yeah, let's just do it.
0.033.
So your first, so we got the number 11 to be 0.995, so we'd fail to reject it, right?
Yeah, failed to reject.
Okay. And this time we use a one-tailed as opposed to
Yeah,
a
the
two-tailed
one
form.
tail.
So
It was 0.006.
and it's 20 for the DF and a significance level 0.01 and it's one-tailed.
Yep.
So are you guys checking the normal probability applet?
Mm-hmm.
Okay.
0.06.
4, 9, 6.
Be left.
And this one matches. This one matches the probability applet again.
So it's 0.5.
Yeah, so 0.497636.
So it decreased, right?
Yeah.
Mm-hmm.
Okay. Cool. And then what decision then we reject it, right?
Yes, because it's below 0.05. Wait, is this one 1?
What?
So what is the significance level?
Point
0.01. So we would fail to reject it because it's higher.
Yeah, it is higher, so we'd fail. Yeah.
Okay.
Okay, wait. I don't understand that.
If it's really, 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 really low, then you reject the null.
Wait,
Right.
what was our p-value?
0.006.
Oh, okay. Oh, okay. Still the same one. Well,
Oh, no.
Oh wait,
That
that's the Z.
p-value.
That's the t-score.
Yeah.
Yeah.
So it was 0.497 was what you said.
Yeah. So the p-value is 0.4976,
Okay.
and
So
that's the same thing on the probability applet.
Right.
Wait, what was the answer we put down for 11?
0.995.
Oh,
Yeah.
okay. Oh, I was looking at a different one. Okay.
So 13 was decreased, right? And so why would we fail to reject it, though? I thought if it was lower probability... Oh.
Yeah, because we
Then-
got 0.01.
So it would have to be lower than 0.01, and it's not. It's 0.47 something.
So we failed to reject it.
Yeah,
Okay.
because the probability of getting that is actually higher.
Okay.
Okay. Compare with the confidence interval.
So the confidence interval for 11, I got to be 23.489, and then 56.587.
So question 13 would be the wider.
Which one is wider? Yeah.
So wait, what did you get for question 11?
On the one sample test, it says that 95 confidence interval,
Mm-hmm.
the lower bound is 23.489,
Mm-hmm.
and the upper bound is 56.587. So now we'd have to calculate the other one.
Yeah. Okay, so
Mm-hmm.
Less than.
6. Okay, I forget how to change it in here.
Oh, hold on.
Wouldn't it be the same?
I think so, because it's still 40, right?
Yeah.
And the numbers are the same. Like the whatever you call it.
Confidence interval.
It's the same. Everything's the same.
Well, the p-value is different though.
Oh, yeah.
That's the only thing that's changing.
But I think they'd just be the same.
Confidence interval changes when your sample size changes. Am I right? And the sample size didn't change.
Right.
Yeah, or the when you change the level of like from 95 to 99. and we
Yeah.
did that.
Yeah,
So I think it'd just be the same.
I think it's
Yeah,
the
because
same.
we didn't change any of those other things.
Yeah.
No.
Yeah, because if we had changed the percent, then that would have changed it, wouldn't it?
Yeah.
Yeah.
You either change the sample size to make it more narrow, or you change
Right.
your 99 from 95 to 95 to make it wider.
And we didn't
Yeah.
do
But we didn't do either of those. So
it. Okay.
All right. Well, should we submit it?
Do it.
Do it to it.
Ah, I'm nervous.
Oh,
Don't
we missed something.
oh,
Wait, did we miss something?
How did I
missed
get it?
something?
It was number 9.
Yeah.
I didn't change it back. I put .040.
You did? No!
Was that from the Google one?
Yes.
Yeah, that was from Google.
What is that
Dan!
website?
Darn it.
Okay, alright. I can't believe that! Oh, dang it.
I will definitely be bookmarking that website.
Okay,
Yeah, what's
so
that
I'll
website?
just... Okay, I could type it out, or I'll just copy and paste it and put in a message. How
Is
about
it the
that?
social science statistics one that you got?
Yeah, that's the one I have.
Okay. All right.
Okay, I'll put that in a message. I can't believe that was right!
Nice.
I have to change it back.
I know, I want to change it.
Oh,
Okay, I just sent it in a message. Lame! I am so mad about that.
I'm gonna have to figure this one out.
all right, sweet. Good
Sounds
job, guys.
Yes.
Alright, good
Awesome.
night.
Alright, see you guys.
Have a good one. Have a good weekend.
Bye.
Okay, bye.